All right, so we got 2 gram penny on a turntable. As you gradually speed up the turntable, the penny flies off when it's turning 1 revolution per second. So we know the period is 1.0 seconds, right? The radius is 0.13 meters. Okay, the mass is 0.002 kilograms, and we want to know what is the coefficient of friction, right? Notice that this is period, right? So in this thing, we're going to set the centripetal force equal to friction. There are 2 formulas for centripetal force. We will choose the one that has the period in it, okay? So we're going to go m 4 pi squared r over t squared is equal to mu times m times g. So let's just plug in our numbers here. 0.002 times 4 pi squared times 0.13 divided by 1 squared, right? 1 revolution per second, or 1 second per revolution. It's the same thing, right? And then that equals mu that we don't know times 0.002 times 9.8. Okay? Notice that the 0.002 goes the way of the bison. Okay, so mu is simply going to be this. I'm going to go 4 times pi squared times 0.13 divided by 1 squared. Don't forget to divide by 1 squared, right? And then I'm going to divide by 9.8. Divide by 9.8. And I get is 0.52369, etc., etc. And there are no units for this thing, right? So if we only have 2 digits, which it looks like we do, we'd say 0.52, right? What is the centripetal acceleration? Oh, we didn't solve for that. We solved for what mu is, right? We didn't solve for what the centripetal acceleration is, so let's do that. That's going to be 4 pi squared r over t squared. So that's going to be 4 pi squared times 0.13 over 1 squared. Let's do that. 4 times pi squared times 0.13 divided by 1 squared. Don't forget to divide by 1 squared. I'm getting, for that, I get 5.132194, etc., etc., meters per second squared. All right. That dog's gonna hunt.